Hello everyone. In this video we are going to solve some subnetting questions. So basically we are going to solve 5 questions from each website from here. Here we are opening subnetting.org. We also uh, have another website called subnettingpractice.com, and finally we have subnettingquestions.com. So without further ado, let's get started. Okay. Here we have a question, says which subnet does host 172.29.91.114/20 belong to? So basically we should know the network address for this subnet. So to be able to solve this question, first of all, I will have to make like a screenshot right here in order to have a space for the solution. So first of all, our subnet is 172 29.91.114/20. To be able to solve this question, we will have to write the binary of this IPv4 address. So let's jump into this. 172 is 10.10.10.11.00. 10, 10, 11, 0, 0. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and 29 is 5 digits. Okay, so we will have 3 zeros. 1, 2, 3, and 1, 1, 1, 0, 1. All right. Here we have 91. 7 digits, so 0. Okay, 10, 11, 0, 11. And finally 114, 0, 1, 1, 1, 0, 0, 10/20. /20, actually here, this address is class B address, so it should be /16. However, this is a subnet, not a class address, not a class B address. So to be able to know how many bits have been borrowed, we will subtract 20 from 16, so we will be left with 4. So that means this, that we have borrowed 4 bits, or 4 host bits, which start from here. 1, 2, 3, 4. From here we have borrowed, or this is network bits. These are now the network bits. So to be able to solve this question, you will have to make everything behind this line 0 in order to know what is network address. So basically the network address is 172 because this is untouched, and actually this is also 29. However, here we only have 64, I guess. 91. 1, 2, 3, 4. 91. Yes, 91. 1, 2, 3, 4. No, 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 no. Actually, 64 plus 16. 64 plus 16. Sorry guys, I'm not so good in math. Plus 16 is 80. So here is 80, and then here is 0. So this address belongs to this subnet. Okay, so if we try to reveal the answer, as we saw here, 172.29.80.0/20. That's it. Okay, let's move on to the next question. This is the second question. Okay, how many subnets and hosts per subnet can you get from network 172.31.0.0/19? How many subnets and hosts per subnet can you get from the network, this network? Okay, so this is a /19. So basically, in order to know how many subnets can we get from this, we should know how many bits we have borrowed. So basically, I think we have borrowed 3 bits because this is a class B address and it's a 16. So if we borrowed 3, we will have a prefix length of 19. So basically, when I write this, we can make like 8 subnets, and each subnet will contain the rest of the bits, or okay, let's assume, yes, 23, I guess. 23. In total, we have 32 bits. If we subtract 19 from them, we will be left with 13. So the network can hold, or subnet can hold 8,190. So basically, if we made a new here number of subnets is 8, and hosts per subnet equal 8,190. Let's try to reveal the answer. Yes, as I said. Okay, alright. So let's move on to the next question. However, let me just pause for a minute. Okay, so here we are going to solve the next question. First of all, let me just make another screenshot for the answer. Okay, which subnet does host 192.168.145.166/25 belong to? As always, 192.168.145.166/25. This is a class C address, so it's a /24. So basically we borrowed 1 bit, only 1 bit. So when we write the address in binary, let's just get our binary calculator right here. 192. Okay. So here we have 1, 1, and 0, 0, 0, 0, 2, 3, 4, 5, 6, 7, 8. Okay. This belong here. And 168, 168, 10, 10, 10, 10, and 1000, 10, 10, 1000. Alright, 1, 2, 3, 4, 5, 6, 7, 8. And 145. 145 is 100, 1000, and finally 166. 10, 100, 10, 100, 11, and oh. Alright, so here we only borrowed this one. So if we cut the address like that, we will be left with this. So here we have 2 plus 4 is 6, and 8, 16, 32. 6 and 32 are 38. So basically we are going to 1, 2, 3, 4, 5, 6, 7. 36 from 166. Let's just 128. No. 128 plus 36. Something's wrong here. 166. Let me just write this down again. 10, 100, 11, 10, and only we borrowed this. So here let's calculate it. 128 plus 64 now, 32, yeah, plus 16, 8, 4, plus 4, plus 2, yeah, that's correct. So if we subtract 32 and 32, we also will subtract 4 and no, yeah, 4 and 6 from it. 128. Actually, this is so. I'm so dumb right now. I'm feeling like I'm really dumb. Okay, so it's 192, 168, 145, and 128/25. So let's reveal the answer. Yeah, correct. So this is our, I guess, second question so far. No, this is the third question. So let's move on to the fourth question. We will make another. What is the last valid host on subnet 172 30.14.0? This is a subnet mask. Basically 255.255 is 16 and 254 is 23, I guess. So basically the address is 172 30.14.0/23. Okay, so here we should know the last valid address on this subnet. Alright, let's write this address in binary. 172 is 10, 10, 11, 0, 0. 30 is No, no, man, no. 30. 1, 2, 3, 1, 1, 4 ones, and 0. 14, 1, 1. Man, I'm feeling so dumb right now. Okay. We have 4 here, so we'll write 4 here too. 1, 1, 1, and 0. And here is all zeros. 23. So the last usable address. Here is all network address, and here is the network bits. So to be able to calculate the last usable address, we will have to, just one moment. One 72, 30, 14. So basically, how many hosts can this network have? We have here 256, I guess, and here only one. One moment, please. I will pause and we'll get back right to you. Thank you guys for sticking in. Actually, in order to solve this question, first of all, we will have to know what is the increment number for this subnet. In this subnet, we have borrowed 7 bits. And if anyone asked how did I know we borrowed 7 bits, here our prefix length is /23. And this class, this range or this number refer to that this address belong to class B address. So, and the class B address prefix length is 16. So if we subtracted 23 from 16, we will be left with 7. Okay. So how to know the increment number? After we know that we have borrowed 7 bits, in this table, we are just sorting our bits values. 128, 64, 32, 16, 8, 4, 2, and 1. From here, we will jump 7 steps. 1, 2, 3, 4, 5, 6, 7. So the increment number is 2. So in order to know the next subnet, we can add 2 to this address. So this address is the first one. If we want to know that next one, we will type 172.30.16.0/23. So in order to know the last valid host on this subnet, we will have to get back 2 steps. So this is the broadcast address 172.30.15.255, and the last one is 172.30.15.254. Let's check it out. I'm a little bit hesitant about this answer, but we will move on with it. Yeah, as I said, right here, 172.30.15.254. Sorry for the bad handwriting. Yeah. So here we know how to solve this type of question. This is the first question. So let's move on to the last question in this website, and we will move on to the next website in another video. So what is the broadcast address of network 192.168.24.68/28? Our address is 192.168.24.64/28. We can also know uh, the broadcast by knowing the increment number. Increment number actually helps us in determining the next subnet, so we can just go back one step to be able to know the broadcast address. So here we borrowed 4 bits because this is a class C address, and the class C address has a prefix length of 24, and if we add 4 on them, we will have a prefix length of 28. So here 128, 64, 32, 32, and 16. 1, 2, 3, 4. This is our increment number. So if we type like that, 192, 168, 24, and we add 16 on this number, basically 64 plus 16 equal 80. This is the next subnet. Actually, if I wrote it like here, the next subnet 192.168.24.80/28. This will be the next subnet. To be able to know the broadcast address, we just only need to get back one step. So the broadcast address for this address would be 192.168.24.97.28. If we show the answer, yes, as we said, 192.168.24.79. This is the broadcast address. So I hope you guys enjoyed this video, and I hope you got benefit from it. We will solve another 5 questions on the other website in another video, and I guess we will make another video for the third website. So I will see you in the next one.